We want all of our students to be successful, to thrive, to grow, and to feel challenged and supported as they learn in our schools. That's not always easy, especially with the diversity of children we often teach. In this session, we will introduce you to the concept of cognitive load and why being mindful of it as we design lessons for our students can help enhance their learning in many ways, while at the same time avoiding the frustration of overloading them. Let's begin by reviewing what we learned about how memories are made in our last session. Our memory model illustration will help us visualize this. Recall that learning is mostly about transferring information that enters short-term memory into long-term memory, where it is stored for later use. It's the dialogue between these two that causes memories to be formed. We are only conscious of the information currently being held in our short-term memory, and we are largely oblivious to the enormous amounts of information stored in long-term memory. That is, until it is retrieved back into short-term memory for use as we interact with it in the world around us. Recall, too, that we said short-term memory has limited capacity and duration. For example, try to remember this number once it disappears from the screen. What is it? Pretty easy to remember, right? But also notice that it has begun to fade from your short-term memory already, unless you rehearsed it in some way. Information in short-term memory lasts only a few seconds, usually less than 30. Now, let's try to remember this number. Any luck? Probably impossible for most of you to remember that one. Why? Well, our short-term memory can hold only about 7 plus or minus 2 bits of information. Notice I'm calling this short-term memory, since it refers to single bits or chunks of information. You can keep it in short-term memory by rehearsing it periodically using the little voice in your head called phonological loop, or by visualizing it using the visual sketchpad. What's working memory then? Working memory is holding information in mind and then manipulating it in some way. For example, consider this number, a number your short-term memory has little trouble remembering once it disappears from the screen. Got it? Now, let's do some work with that same number. Remember, it's 74832. Next, take each number in sequence, add 1, and then say the resulting 5-digit number out loud. What did you get? Here's what you should have ended up with. This is clearly harder. Why? You had to hold the numbers in your short-term memory and manipulate or work them in some way. Hence, we call this working memory. Here's another example of working memory. Multiply these two numbers in your head, 43 times 21. Again, pretty hard to do because you had to manipulate or work with what was in your short-term memory, multiplying 43 by 21. Most people try this calculation in one or two ways, visually or phonologically in their head. That is, you visualize the numbers in your working memory, or a little voice in your head recited the numbers as you tried to do the multiplication. Some people use both pathways when they are processing things in working memory. Others of you might have used a strategy retrieved from your long-term memory by breaking the multiplication into parts. 43 times 20 equals 860, plus 1 times 43 equals 903. We often augment our working memory through using long-term memory. This all means that working memory is even more limited than short-term memory. When processing or manipulating information in working memory, learners are able to manage fewer items of information depending on the type of cognitive processing required, sometimes much less than the 7 plus or minus 2 chunks of information for the short-term memory. Now, why is all of this important for learning? Well, it's in working memory where we do our thinking, decision-making, problem-solving, reasoning, and just plain making sense of the world around us, both in terms of incoming sensory information and what we retrieve from long-term memory. For example, think about trying to decide what you want to order at a restaurant. You will likely process a variety of factors as you decide, both from your immediate environment, the menu, what people at the table with you suggest, what you see or smell in the restaurant, what the waiter says, and also what you retrieve from your long-term memory, what you ordered before at this place, what a friend previously recommended, your dietary restrictions, how hungry you are, and so on. You might also be distracted by the conversation going on at the table or your cell phone vibrating in your pocket. All of those things will be held in working memory at various times as you make a decision about what to eat. That same thing happens when our students are learning something new in school. We take in relevant information from our learning environment and at the same time usually retrieve information from our long-term memory in order to make sense of what we are seeing or hearing. But at the same time, we might be distracted in various ways, which will take up part of working memory in less than productive ways. Since memories are formed through that dialogue or active processing between working memory and long-term memory, as we discussed in the last session, having working memory operating at its maximum capacity is important for optimal learning. So it is critical that our students are able to process things in working memory efficiently and flexibly without overwhelming its capacity. This is where the concept of cognitive load comes into play. Cognitive load is formally defined as the total amount of mental activity imposed on working memory in any one instant. Unfortunately, and too often in learning situations, students can be cognitively overloaded, which significantly impairs their learning. For example, consider a student studying in her room doing history homework. We hope that a maximal amount of her working memory is being used to focus on her reading her history text. However, if she is partially attending to any text messages coming through on her cell phone and is also distracted a bit by her little sister practicing piano in the next room, then her working memory available for paying attention to her history reading is reduced. In other words, her cognitive load is high and her learning becomes less than optimal. In addition, if the history reading contains a lot of new vocabulary words and requires some prior knowledge she can't easily retrieve or doesn't have, then what is already a high cognitive load may actually become overloaded, and as a consequence, not much learning will probably happen during this study session. The same thing can and does happen in classrooms. The challenge for us all is that the cognitive load in the same learning environment can differ from child to child. Knowing how to diagnose and respond to this is one key to effective teaching, since working memory is the gateway to long-term memory, and learning happens best when it is operating at full capacity without being overloaded. As teachers, there is much we can do and even should avoid to help our students manage their cognitive load. For those interested in learning more about cognitive load and its instructional implications, please see the Teaching Strategy section of our MOOC under Cognitive Load for a variety of suggestions and ideas about how to translate the learning concepts in this session into teaching strategies for your classrooms. We'll talk more about working memory and its critical role in learning in future sessions, especially when we discuss multitasking. In summary, the take-home message for this session is that all learners can process only a limited amount of information at a time. And it's the active dialogue between working memory and long-term memory, where durable memories are made. So we need to be mindful of our role in overloading our students' finite working memory capacity to process what we want them to for effective learning. In addition, we also need to encourage them to be equally mindful of how and where they choose to study and learn, a topic for a future session about self-regulated learning. The next session will continue our overview of memory and learning, and we'll be looking at how a student's prior knowledge is a key consideration in designing effective learning environments.